So if you look over here at all of the Word Club words, we have a lot. So lots of new words coming up today. It's important that you pay attention. First off, we have a prism, which is a three-dimensional figure with at least two parallel congruent faces that are called bases that are known as polygons. So a prism, two parallel congruent faces. So if I look at this shape right here, this polyhedron, my base would be these two sides right here because they are two congruent parallel faces. So if I set this on the side, I wonder if you can see in this video, this would be my base, right? Would that base ever touch this base?
No.
They are parallel to each other, right? So this is a prism because these two faces are completely parallel to each other. I know that they are the bases because they are parallel. So you will always have two bases on a prism. Okay. So this shape right here is a prism because I have two parallel bases. Okay. If I have a pyramid, it's a three-dimensional figure with one base that's a polygon. Okay. So a polygon, remember, that's just at least a three-sided figure. So my base is a square. All the other sides, faces, are triangles. So a pyramid will always have some type of polygon as a base, and then all the other sides will be faces. Okay. So how many bases would I have for a pyramid?
One.
Just one, right? Where we said for a prism, how many do we have?
Two.
So a prism has two bases, pyramid has one base. A pyramid has all faces that are triangles except for that one base. But that base can be a triangle as well. Okay. All right, so if you're looking at these examples, number one, that first 3D object, is that a prism or a pyramid?
Prism.
A prism, because it has at least one set of bases that are congruent, right? I could say these two sides are the bases, or I could say that top and bottom is my base, or the front and back, right? It doesn't matter because it's a rectangle. But that does let me know that it's a prism because I have at least one set of parallel bases. What would this figure be?
Pyramid.
A pyramid because I have one base and then all my other faces are triangles, right? Okay, what about this third one? It's a pyramid as well. What about that last figure?
Prism.
Why is it a prism?
Because it has triangles and the polygons that are parallel.
Those two triangles right there are parallel to each other. So those are my bases, meaning that this is a prism. Good. Remember, just because that rectangle is what it's sitting on doesn't mean it's its base. Normally we think whatever it's sitting on is base, right? Base is bottom. But in this case of a prism, it doesn't matter because it can sit right here on this face, right? But is that one of my bases? No, my bases are the two parallel ones. So don't always think that whatever shape is on bottom is that base, because that's not always the case. All right, any questions about determining whether it's a pyramid or a prism? Okay, go ahead and flip over. All right, next we have a plane, which is a flat surface that goes on forever and ever. So, this, the outside picture right here is what's representing our plane. It's a flat surface that goes on forever and ever. It never ends. Okay. Inside this plane right here, I have the rectangle, or the square ABCD. If I look at line segment AB and line segment CD, those are coplanar because they are in the same exact plane as each other. Okay. They're also parallel because clearly they would never touch. So just as we have two lines in a plane that can intersect, so AB and AD would be intersecting, right? Or just how we can have them parallel, there are different ways that planes can be related in space. So if you look at this first example, I've got two planes that are intersecting. They are intersecting at a line, though, this line right here. Okay. But if I have three planes, like shown in this picture, they can't intersect at one line. They are going to intersect just at one single point. Okay. So 2 planes can intersect at a line, a single line. More than that is going to intersect at just one single point. Okay. And then, of course, we can have planes that have no intersection, so those would be parallel planes, meaning that they never ever touch. Okay. Any questions so far? Okay. So when we have these intersecting planes, they can form those 3D figures. A polyhedron is a 3D figure with flat surfaces that are polygons. So that means that every single surface of that polyhedron has to be flat. You cannot have any curved surfaces or else it is not a polyhedron. Okay. And then we have a few different things about those polyhedrons. So looking back at my figure right here, I've got what's called an edge. Okay. An edge, it tells me, is where 2 planes intersect in a line. So my edge, maybe I should use this one so it can be on video too. My edge would be like this flat line. Can y'all see this if I do it up there? So that is an edge. This right here would be an edge, okay? This would be an edge. This would be an edge. Okay, so basically your edges are all of your lines, your line segments on that shape, okay? Then I have what's called faces, which is just our flat surface. So this whole thing would be a face. This is a face. This is a face. This is a face. Okay, so I should have 1, 2, 3, 4, 5 faces on this figure. Okay, so my faces are my flat surfaces. My vertex, that's where 3 or more planes intersect at a point. So if you look right here, this is a face or a plane, this is a plane, and this is a plane. The point where they all 3 meet together is right here. So that's my vertex. Okay, so it's basically all the corners of that figure are your vertexes. That makes sense? Okay. So, edge, my lines, my vertexes are all my corners, all my corner points. Then my faces are just those flat surfaces that makes up the 3D polyhedron. Make sense? Okay. If I have a diagonal, it's a little bit easier to tell from this picture that they've drawn. It's kind of like if I was going to cut this object all the way through or draw a line all the way through from this corner to this corner, but going through the object. Okay. So it's going from one corner to that opposite corner through that shape. That's your diagonal. Okay. Any questions? Okay. So we just said that a polyhedron is a 3D figure with flat surfaces. So if I look down here at the cylinder and this cone, do they have all flat surfaces? No, they have curved surfaces, right? So like this whole part of the cone, that is curved. This whole part of that cylinder, that's curved. So can it be a polyhedron? No. Remember, polyhedron can only be a polyhedron if every single surface is flat. But these are still 3D objects. They're just not polyhedrons. They're just simply a cylinder and a cone. Okay. All right, so let's look at these 3 examples. They have done them for us, but we're going to go through and figure out how they got their answers. So first off, we are naming the figure and then telling what the bases, the faces, the edges, and the vertices are. So first off, is this a prism or a pyramid? This would be a prism. But I want to be more specific. I don't want to just say it's a prism. I want to look and see what those bases are, and whatever shape that base is, that's what type of prism it is. So where are my bases here?
The 2 triangles on the side.
The 2 triangles on the side, okay? So if they are triangles, then that means this is a triangular prism, okay? So you're going to name it by whatever shape that base is. So just like we just said, these triangles are my bases. So ABE and CDF would be my bases. You're just naming them by those 3 vertex or points. My faces are also those 2 bases plus the other 3 sides. Okay. So this front triangle or rectangle, this bottom rectangle, and then that back rectangle. So those would be all my faces. Okay. So your faces include your bases. And then my edges, those are just my straight lines. So AB, BC, CD, but they are called line segments. So that means when you're writing them down, you have to put that line over your two letters, because that tells me that that is line segment AB, line segment BE, and so forth. Okay, so you can't forget that line over the top. And then my vertices, those are just all those corner points. So every single letter listed. All right, so let's do A together. Is it a prism or a pyramid? Do I have any faces that are parallel to each other? No. So this is a pyramid. What is my base? What shape is my base? A triangle. My base would be right here, JML, right? So how would I name the figure?
Triangular pyramid.
Triangular pyramid. So now we need to label our base, which we just said was JML. Does it matter if I say JML or LMJ or JLM? It doesn't matter as long as, on a triangle doesn't really matter, but as long as you're kind of going in a circular motion. So like on a rectangle, you don't want to go from one side to the other side and so forth, which I'll show you when we get there. All right, so my base is JML. Is that also a face?
Yeah.
Yes. What's another face?
JMK.
JMK. Okay. Madeline? K what? KML. And last one? Enter.
JMK.
We already have that one. Amy. KJL. It's that first front one. JKL. Okay. So I've got 4 faces. All right, what about my edges? Somebody tell me what one edge is. Cool. JK. What do I have to put on top of them?
The line.
I have to put that line to tell me that it's line segment JK. All right, what's another one?
ML.
ML. Okay. Okay. What? KL. Okay.
JM.
JM. Okay. What's that, Lyndon? KM. Okay.
Is that all?
We should have one more. We're missing one. Madeline. LM. Yep. Oh, yeah, we do. ML. Madeline. JL. Yep, that's our missing one. Good. So we have 6 edges. All right, what are my vertices?
JKL.
Okay. JKL. Any questions on naming those vertices, edges, faces, bases?
No.
All right, at the bottom it says a cross section is an intersection of a solid and a plane. So let's see exactly what they're talking about. By a cross section, that means we are basically cutting these 3D figures into 2 pieces and figuring out what type of figure is formed. Okay, so they want us to cut it vertically, angled, and then horizontal. And we have a square pyramid. So I've got my square pyramid, and then this rectangle is showing how it's getting cut up and down vertically. Okay. So you want to cut that pyramid in half. So if I were to take this and cut it from top to bottom, and then you want to look at the inside and see what the inside shape is. So if you look right here when it's sliced, what does this middle piece right here form? What does that make?
Triangle.
A triangle. So the cross section, when this is vertically sliced, makes a triangle. Alright, what about if I slice it kind of at an angle? What does it make right here in the middle? It's not quite a square.
It's around it.
This makes a trapezoid. Okay? It's kind of hard to see. If my picture was a little bit bigger, I think it would be a little bit clearer. But these two sides are parallel, but if you look at these two sides, they kind of kick out a little bit.
I see it.
So they are not parallel, meaning that that is a trapezoid. And then if I slice it horizontally,
Then it makes a square.
then it makes a square. So your cross section is finding out what shape is formed when you cut it in two. Okay. So in B, they want us to figure out the cross sections of a cylinder. So if I slice it vertically, so basically kind of think of like a cup. If I were to slice it right down the middle and then turn it out like this, what type of shape would it make? A rectangle.
Who said a circle?
So if I slice it vertically, it's going to make a rectangle. What if I slice it at an angle?
Oh.
So like if I take this and slice it kind of at an angle. Think. Gabby. An oval, right? If I sliced it horizontal, that would give me a circle, right? But if I do it angled and kind of stretch it a little bit that way, that would leave me with an oval. Okay. So angled slice would be an oval. And then horizontal is what I just said.
It would be a small.
Horizontal would just be what?
It'd be a circle.
A circle.
Cylinder.
Okay. Any questions on that?
No.
Alright, let's do our guided practice.
No.
We need to name this figure first. So is it a prism or a pyramid?
It's actually.
It's a rectangle.
What is it, Lyndon?
A triangular.
A triangular prism. These two triangles right here are parallel to each other, telling me that it's a prism. And they are both triangles. So this is a triangular prism.
Yay.
What would my bases be?
QRS.
Good. Those two triangles. So QRS and TUV. Alright, are those two bases also my faces?
Yeah.
Yes. And then what other faces do I have?
QSVT.
QSVT. Okay. That side rectangle. Okay. Henry?
UVSR.
UVSR. Okay. Good.
Yeah.
QTRU.
Good. That back one. QT. Hold on. I have to go like in a circular motion. So if I'm starting at Q, that means it has to be QTUR or QRUT. Okay? Does everybody see that? So you can't go QUTR or QTRU. You have to move in that circular motion. Okay? So QTR. Did not mean to put commas in there. Sorry.
Oh my god. That's just. Wait, now it's gone.
What am I doing? QTUR. Whew.
QTRYT.
QTUR.
It's white out white.
Right, is that all my faces?
I think
Okay.
so. I hope so.
So what about my edges? Akaria. What about edges? Madeline. TV. Okay. What do I have to put on top? That line. Okay.
I like TV.
All right, Ella. What? SV. Okay. Addison. QT. Okay. Madeline. QS. Okay. Madeline. SR. Good. Ella. UV. Good. Okay. Desmond. RU. Alright. Another one. Madeline. QR. We don't have that one.
There's no G, so no.
Okay. We're missing one. Henry.
QROSR.
Madeline. TU. Yep.
Oh my god.
No, we didn't see.
TV is what we did first. Can y'all see that okay up there? Kind of small.
Shame on you. Smart. We got us in Nathan.
Alright, what are my vertices? Somebody other than Madeline. Asia.
Okay, I still got the verse. Oh, wait. QRSTUV.
Okay.
You got it.
QRSTUV.
Wait, what?
So that's just all of those corners. Okay. Any questions about that? Alright, number 2. What is the shape resulting from that cross section? Ella.
Is it a?
Ella. Jorge, is your name Ella? This is a triangle.
You're so. You didn't know that?
Alright, number 3. How can knowing the shape of the base of a 3D figure help you to name that figure? Nathan.
There are two bases. What? You can find out what the.
If there's two bases, that just tells me that it's a prism, right?
Yeah.
So how can knowing what the shape of that base is help me to name it?
The first word.
Okay, so if my base is a rectangle, what does that tell me?
It's a rectangle.
Then it would be a rectangular prism or pyramid, right?
Uh-huh.
Stan.
Because the name of the shape is associated with the name of the base.
Uh-huh. Keep going.
The name of the base would be the
Associated
Yes.
with the name of the figure, right? But is it true for all 3D figures? Think about a cone and a cylinder. Is it true for those? No.
Cube doesn't have to do with the base.
Right, so it's not true for all, but it's true for most. So we will say some 3D figures are named by their bases. Enter. So some 3D figures are named by their bases. Alright, any questions? Alright, you are working on the rest of this packet from now until you leave. And this is also your homework if you do not finish.